And again, this transition zone is in the middle of the mantle. And not too long ago, while studying the rocks that come up from this area, they found evidence that there may actually be water located in this transition zone. And not just a small amount of water, but possibly more water than all of the Earth's oceans combined. Now, the one thing is, it's not water in its liquid form. It's water that's been trapped inside the rocks in a molecular form. Because of the higher pressures in this region of the Earth, the hydrogen and oxygen molecules are absorbed into the rocks in this region. And almost all the rocks in this transition zone are saturated with the imprint of this water. And again, this isn't water in a liquid form. It's water that's broken down to a molecular level because of the density and the high temperatures in this part of the Earth. The water literally fuses into the rocks in this region. But in order for that to take place, the water has to get down there first. And so just like we have water cycling into the crust, that same water is also going down into the mantle and even deeper down into this transition zone. And this isn't an instantaneous process. This is something that's taken place over a long period of time, hundreds of thousands of years. So this water has been cycling down to this depth throughout multiple different stages of the Earth. And throughout that time, this water has had a chance to impact this area as it cycles through it. And that's something that they found, that when seismic waves go through this region, the S waves disappear in certain places, which suggests that this isn't a completely solid layer and that there are depressed sections all throughout this region. So it seems like the water that has been cycling through this region over thousands of years has had a strong effect on it, which makes sense because, again, remember, wherever you have water and you have rock, you have the potential for cavernous areas to form. And we know generally this is a process that happens over thousands, sometimes millions of years. And there's definitely something to this because in 1994, you had the second largest earthquake in recorded history in Bolivia. It was an 8.2 on the Richter scale. And so, of course, this thing sent waves throughout the entire Earth. And they were able to use those waves to map the Earth on a large scale. They were able to see parts of this transition zone that had rough and almost mountainous sections. They're actually referring to them as mountains because in that same boundary with these structures are smooth plains. And we know there's just no way you can have mountains and plains in a completely solid object. In order to have mountains, you just by default, you need open space around it. And they're saying that these mountains are sitting right at the base of the transition zone. So the foot of the mountains, the lowest part of the mountains, stops right at that 660-kilometer depth. And when they mapped the top of the transition zone, none of this was there. It's not until they started going lower down that they started seeing these mountainous regions and these plains. So it's literally like the layout of a landscape. And from what they could see, these mountains could be bigger than anything that we have on the surface, which is crazy because you got to think the tallest mountain on the surface is Mount Everest, and that's 29,000 feet. So, just how tall are these mountains? But they're saying that the topography of this 660-kilometer boundary is just as complex as the Rocky Mountains, the Appalachians, just as complex as anything that we have on the surface. Now, one of the things that they found that could be causing this, they found a couple of years ago when they were able to sample diamonds that came up from this region, from a mine in Botswana, because, Africa, the land of diamonds. They were able to recover a diamond from this region. And they found that this diamond contained water, and not liquid water, but actually water in the form of ice. And it's a completely different form of ice than we have here on the surface of the Earth. They actually call it ice 7. They can form at almost any temperature. Literally, this ice will be at a solid state, even at room temperature. Only thing is, it's only stable at high densities. So outside of a high density environment, it goes back to a liquid form. This ice is only stable and can really only exist at this 660-kilometer region. From what they think, this region is filled with this ice because they found temperatures of 60, 90 to 120 Kelvin just above the middle of the mantle. So we're talking about well below freezing temperatures between negative 300 and negative 200 degrees Fahrenheit. And then in the middle of the mantle, inside the transition zone, they were getting readings of 60 or even possibly 300 Kelvin. 300 Kelvin, we're talking about 80 degrees Fahrenheit. Temperatures that we would normally expect to find inside of a cave, nowhere near that estimated 2000 degrees Fahrenheit. But as they continued to map out what was going on down there, they noticed that when the oceanic crust would sink down deeper into the earth, that it would go straight to this transition zone. And that this oceanic crust was actually sitting at the top of the transition zone. This oceanic crust is literally layered across the top of the transition zone like slabs. And these were actually cold slabs that are affecting the temperature of the transition zone. And they're not just sitting on the top, they're also on the bottom and even penetrating through the transition zone, almost like stalactites in a cave. And these slabs are not moving. They're stagnant right at the top and the bottom of the transition zone, almost like they're literally trapped in place, like a barrier around this region. And they say it's literally like this area is shielded from any of the geothermal activity going on in the lower mantle. And there's no type of anomalies like this going on below this 660-kilometer discontinuity. And they've been trying to figure out why these labs are not moving, but they really don't know why this is happening. Again, like an anomaly in this particular region of the mantle, but there's literally no signs of these things moving. Again, they're acting like a barrier above and below the transition zone, and they're staying at that cold temperature. It's like they're completely unaffected by the thermal activity around them.